Adaptive Engineering. A Game Changer in Systems Development, by Vinny DiGirolamo. This morning I'm going to introduce you to what I see as the next step in the evolution of engineering methodologies, called adaptive engineering, and what I believe to be a game changer in systems development. Appropriate to this presentation, the photograph here was created by an AI art generation program with the abstract of this presentation as its primary prompt. I thought it was cool looking. Thank you for considering these concepts. If you have any questions related to this presentation, my contact information is provided at the end of it. As I prepared this presentation, I felt a keen sense of responsibility and even ownership for the engineering, development and acquisition processes I've worked within for the past 40 years, in and out of uniform, for both nuclear and tactical programs, from warfighter to lead systems engineer, resource sponsor to DoD consultant, and from business owner to my current position as program manager for a major DoD contractor. Here are my objectives for this brief presentation. I will define and introduce adaptive engineering, discuss its foundational building blocks, hierarchy of experience and needed competencies, introduce what adaptive engineering adds to the systems development equation, and finally suggest ideas on a way forward. I labored over this definition, but think it captures the essence of adaptive engineering in a nutshell. Adaptive engineering, enhanced by generative AI and data in motion concepts, is an all-encompassing systems development process that amalgamates and builds upon established methodologies and processes. It addresses distinct project phases, dynamically adapts to evolving requirements, leans heavily on user feedback, and optimizes every phase of a project's lifecycle. As these concepts were successively introduced to the engineering community over time, they added some specific features and processes to help facilitate the development of complex hardware and software systems. In the sake of time, I list a few of each of their intended enhancements here, but I will focus attention on three of them: systems engineering, mission engineering and of course, adaptive engineering. The systems engineering, V, is a time-tested, high-level representation of the key processes all systems must go through to design, manufacture, test, and field something. Anything tangible that is engineered properly has followed this roadmap for the ages. I often warn decision-makers who want to shortcut that V, in some way, like skip a step, that there will be consequences later on and more costly than beating the well-trodden, proven path outlined here. In 2020, OUSDR&E released a new systems development process they call mission engineering. About a year ago I learned about R&E's published guide from a friend in DC circles who recommended it to me, and I was immediately captivated by its many tenets, placing the focus squarely on the mission, its characterization, and upfront and early user involvement. I created the mission engineering, M, to simplify what I believed captured the intent of the freshly published guide. It incorporates the systems engineering, V, but adds two more legs: the upfront requirements development leg that I don't think we ever spend enough time on, and the post-fielding leg which extends to systems retirement, which is often neglected during the requirements development phase. As a requirements advocate, I see DoD's focus on the first leg of the M as a key ingredient to a program's success, and user involvement up front has been discussed for decades. Steve Jobs had it right as he built Apple on one major concept: user feedback. Once the M was created, I could easily see four phases or roadmaps, including requirements development, design to manufacturing, fielding, and finally retirement. I decided to build on R&E's concepts and evolved the mission engineering, M, with additional concepts and relabeled it adaptive engineering. I consider this a potential game changer in both acquisition and development communities, and I will explain why in the next few slides. Flipping the V part of the M, made for an easy representation and in the process, did not lose any of the salient process blocks represented in the M. However, adaptive engineering introduces several new concepts, including data in motion visuals, mission experience or MX, and artificial intelligence or AI concepts, and it allows the flexibility to choose or adapt the system's development approach throughout the system's lifecycle, regardless of what was set in motion initially. All four mission engineering roadmaps were preserved, but what really changed here is the mindset that allows for the continued evolution and use of applications, tools, technologies, and systems development processes now available to us or on the immediate horizon, all accelerated by extended reality tools and recent advances in accessibility to generative AI capabilities. What adaptive engineering adds to the equation? Adaptive engineering builds on all previous systems development concepts and principles and gives us the adaptability or flexibility to choose best practices at any particular phase in the project. We adapt to current or evolving circumstances. It adds data in motion concepts I will illustrate using a DODAFOV1 diagram. It introduces mission experience concepts which integrate user experiences throughout a mission scenario's timeline, facilitated by readily available visualization and virtualization technologies. Then there's the real game changer. Adaptive engineering embraces artificial intelligence applications throughout a system's lifecycle from start to finish, capability inception to retirement or replacement. Here is a simple data in motion concept on an OV1 illustration. It's an animated improvement in understanding. Bandwidth, data flow, and relative speed of data is roughly depicted for engineers and non-engineers alike. More can be done with this OV1 to illustrate the sequence of events as the mission is characterized. Animation tools and services used to be expensive but are now readily available to all. So, why not use them more vigorously in developing a system's architecture? You are all familiar with what UX, or the field of understanding and designing the interface between human and machine. Here, we take immersive UX to the next level in a dynamically changing virtual environment easily facilitated by today's extended reality or XR tools and simulation technologies. Mission Experience, MX, is a dynamic, virtual immersion of a user's experience, UX, throughout a mission thread or scenario's timeline using an array of extended reality, XR, tools, and modeling, simulation, and analysis methods. UX developers create the different user interfaces for each instantiation of equipment and operational environment, which includes different needs, perspectives, responsibilities, environments, equipment, and networks, to name a few. Mission Experience runs the entire scenario real-time in a simulated virtual setting to wring out the gaps, inconsistencies, and unsatisfied or emerging requirements from user and engineering perspectives. The MX timeline here is a depiction of an MX test in progress, a hypothetical mission timeline with specific assets, associated equipment, and orchestrated operations. Tectonics, as a small company on the leading edge of UX design, provided me with these interface examples. They are currently designing modular open system architectures for scalable control interfaces that bridges the gap between users in distributed environments. When DIA is able to vet requirements and characterize mission scenarios virtually, economies of scale in reduced budgets, time, labor, and improved mission capability capture can be realized. The Witch's Brew is composed of all of the requirements, metrics, processes, architectures, tools, and capabilities you have at your disposal, whether in-house or contracted out. They exist today. I looked at what talent would be required to accomplish those phases. Of note is the need for gamers fresh out of high school or college. MX is the full immersion of the user in the mission space, or what I refer to as gamification, where the user's capabilities and experiences change as the mission scenario proceeds. Yes, younglings that have experience in fully immersive games will help us develop systems of the future, systems that they will in turn use. Make sense? Artificial intelligence is the real game changer. AI is not the future, it is now. AI applications are being exponentially built daily for every aspect of our acquisition, engineering, and business development, logistics, testing, and training processes, to name a few. And AI is not going to degrade in capability going forward. How many here today have some level of experience using AI applications in the development of any of your proposals, products, processes, or documentation? If not, why not? I mentioned two examples here where AI assisted my team with answers. One where we had to process lots of data at light speed for answers where AI helped design the formula to cut to the chase, and another suggested systems engineering competency areas and testing material in record time. Remember, you cannot take the human out of the loop using AI as a consultant. Understand what you are looking for before AI provides it, and consider your organization's policies on AI before going all in. Requirements creep plagues many programs, and in some cases is inevitable. Spending more time on the requirements up front and characterizing the mission accurately can go a long way to prevent requirements creep. It is always a costly situation when you hadn't considered the inevitable or even the obvious. We need to spend more dwell time on requirements and mission characterization activities using all the tools available to visualize and virtualize the desired capabilities, but also consider requirements for every stage of the entire life cycle up front and not as an afterthought. AI applications can be used, and in some cases are being used, to influence all stages of the life cycle, illustrated here. AI applications influencing each stage can be homegrown, Open source or purchased. Pandora's box has been opened and AI is this generation's opportunity to improve and optimize everything. Adaptive Engineering Management Plan, instead of the SEMP, would be created to include a section on industry's approach using AI applications, data in motion visuals, and mission experience tools during the design, development, and lifecycle of the program. This document would also evolve as AI technologies advance or are created, and so would the deliverables as the system is being developed or sustained. This is a hierarchy of needs for what that ideal adaptive engineer would have to have experience in to be effective. AI helped me identify 50+ competency area suggestions. The third note still stands: the success of a development program, no matter how adaptive or AI-enabled you are, is based on good judgments during its evolution. The human is still in the loop. If I were king for the day, here are some of my ideas on a way forward. First, I am encouraged by DoD's recent initiative to stand up Task Force Lima to better understand AI's use in DoD. I wish I could be a fly on the wall as they develop their approach and select their experts. Don't forget the gamers. I recommend you start with a self-assessment of your organization's development capabilities, dig into the R&E Mission Engineering Guide and adopt its core principles, and then take a leap of faith into the world of adaptive engineering, AI, and MX, even if you are only adopting the mindset to adapt. On a final note, I recently published a book titled Pentagon Think, which includes vignettes on mission and adaptive engineering. Otherwise, if you have any questions, please feel free to reach out to me. Other videos are available on the links listed.